filter. For each version, I'd like to register what's the DC component value, absolute value. In this case, 7.63. So I want to register AC component. You need to switch your voltmeter to AC mode. So let's make it 12.25 decimal positions. Already you can see that even though shape of the signal is far from our mental picture, rather of DC voltage, rather we would expect a straight line, you can see that share of DC component in this signal is over 50%. One is 64.2%. Now we can improve this signal by adding looping capacitor inside the resistor. So let's run. First, let's analyze what we expect when we add this capacitor. If the capacitor will charge, when the voltage increases, our capacitor will charge to two conducting diodes. The resistance of conducting diode is very small, which means that time constant in this circuit will be very small. It will be close to zero, so voltage across the capacitor follow practically at the same rate the input voltage. So the capacitor will charge to the peak value of the voltage. However, when voltage starts to drop, the capacitor will discharge. But it will discharge not to diode, but to the resistor. So since resistor is 1 k we have we have 100 milliseconds. 100 milliseconds. This is time constant for the circuit, and how much the capacitor discharge will discharge, it depends on this distance between these two peaks. So the distance is exactly 5 milliseconds because frequency of our signal is 100 Hz, so it means that the period of the signal is 10 milliseconds, and the distance between these two peaks is exactly half of the period, 5 milliseconds. So we have 100 milliseconds against 5 milliseconds, which means that time constant of the circuit is 20 times greater than this distance between these two peaks, which means that the capacitor will discharge but just a little. Let's see first what will happen if I make this capacitance 10 microfarad. So now my time constant is 10 milliseconds, which is only twice as large as this time disk. And you can see that voltage drops, but still, no, doesn't look like a series of bumps, but some jagged straight line. As you can take closer look, if we remove DC components from the signal, so we need to switch to AC coupling here in your oscilloscope. And now we can see only this variable component. So you can see that the peak value here is 2.40 volts. So this change is significant, but it's still much better than the previous. So when I increase the capacitance 10 times to 100 microfarad, what I expect that this AC component should decrease roughly also about 10 times. Let's see. And so now you can see that there are some ripples across this straight line, but it looks much better than the previous. Again, we can take further look by removing DC components from the signal and increasing to scale under observed for division. You can see.
Yeah, can I ask a question?
Sure.
I took my research and I see that I had 0.1 explain this for.
Well, most likely, well, there are two possibilities. Either you didn't submit your work. Did you submit to Platon?
So, I can't submit Platon because there was a problem with Platon, the first pattern. And I was confused with delay.
Well, so if you send but you didn't send from your student account. So, as I said, in general, there are two possibilities. Either I didn't receive your wealth, that's one possibility, that's right, or you did everything wrong. One of these two, basically. So, you can send me email with your full name and ID, so I will later when I will put some moment I will talk.
Okay, so I will simply ask the question.
Okay, so what you can see now that this peak value of this variable component is 233 millivolts. So indeed it's roughly 10 times smaller. So you reduce it by 10 times, you can still increase this capacitance to 1000 microfarads, which is 1 millifarad, and now our time constant is 1 second. So it's still even smaller, and indeed, our AC component is only 19.1 millivolts value. However, this value is drawback as well because it's rather sensitive to load resistance value. When I decrease, for instance, load resistance from 1 kilo ohm to 100 ohm, you can see that this variable component is greater again. And again, we have 200 millivolts. So it's sensitive, but we can somehow cope with this by using some large capacitors, like 1 millifarad or even several millifarads. Anyway, let's get back to this original value to 100 micro and 1 kilo ohm. So this is what we see now on our voltmeter with AC component. And you can see huge improvement with respect to the previous version, because in the previous version AC was 4025 millivolts, now it has only 145 millivolts. Let's check my DC controller. And DC component is 12.46. So percentage share of the DC component is 98.8%. Pretty close to 100%. But let's see how it can be better. And the last variant, which you can see the instruction, the second one, this is the last one, so we can bit more amplitude. We attach to Zener diode, and now remind, Zener diode is a diode which usually works in reverse bias, and it's constructed in such a way to facilitate this working in the breakdown mode. The breakdown voltage for Zener diode is in the range of a few volts, 2, 3, 5, 11. You can find diodes for different breakdown voltages, but in general they are not as high as for ordinary diodes. And when this diode goes into the breakdown mode, the voltage across the diode is pretty stable. It doesn't change much with current flowing. So we can use this property to stabilize this voltage across the capacitor. The voltage across the capacitor will vary, however, as long as it will be above breakdown voltage of the Zener diode will be working in the breakdown mode and will stabilize this voltage here. The voltage across the resistor should be equal to the breakdown voltage of the diode. As you can see, there is a resistor added to the series with diode to limit the amount of current flow. When the diode is working in the breakdown mode, resistance is very small, it's close to 0, so each current should flow to the diode and it should be stable, so we need to somehow limit this current flowing, and we do it by adding this resistor. But check